A driver was transferring gasoline from a tanker trailer to a tanker truck when the gasoline vapors ignited and exploded. The driver sustained fatal injuries. A spark from static electricity likely caused the ignition. Static electricity is invisible because there are no warning properties. In the presence of a flammable atmosphere, it represents an extreme workplace hazard. Static electricity is generated by hydrocarbon fuels as they flow through hoses and pipes and move around in tanks. Because of their chemical makeup, these fuels can not only generate a static charge, they can store the charge and transfer it to other things. When built up, static electricity can discharge by jumping to the nearest conductor of lower charge, generating a spark which can ignite a fuel-air mixture. To eliminate or control static electricity, methods including bonding and grounding are used. Bonding uses a conductive material, such as wire, to connect components such as the pump, hoses, and nozzles in a fuel delivery system. This prevents sparks by keeping the charge between components the same. Grounding dissipates the static charge to the earth. At operations where fuel is stored, handled, or transferred, grounding systems are designed and installed by qualified persons. At the incident site, fuel was stored in tanker trailers and a tanker truck. At least 8 months earlier, to facilitate the construction of a concrete block wall, the parking location of the truck and trailers was changed. During the work, the grounding rods at the original parking location were removed. This meant the site had no grounding system. On the day of the incident, the driver had fueled the tanker truck's fuel tanks with diesel pumped out of one of the tanker trailer's compartments, using the dispensing hose on the truck. The dispensing hose was non-conductive and was not bonded to the nozzle, pump, or tank. There were no markings on the hose to indicate whether or not it was conductive. The driver needed to transfer gasoline from tanker trailer 1 to the tanker truck for delivery to a customer. The transfer hose was fitted with a bonding wire so that the tanker and truck had the same charge or electrostatic potential. To perform the transfer, the driver could top load or bottom load. Top loading could be done by using the dispensing hose to load the fuel through open access holes on the top of the tanker truck. And bottom loading could be done by connecting the dispensing hose directly to a fuel loading valve, or by connecting a different hose from the 3-position valve to a fuel loading valve. There were 2 safety advantages to bottom loading. First, the system is essentially closed, so almost no oxygen is introduced into the fuel handling and storage system. Second, bottom loading can be done from the ground, with no need for a worker to be on top of the tanker truck. The employer's Safe Work Procedure, or SWP, for top loading did warn against splash loading and said that a nozzle extension could be used to avoid it. This is important, as the turbulence created by splash loading generates static charge. The SWP also said to ensure bonding and grounding, but didn't say how to bond. And with no grounding system in place, it wasn't possible for the driver to ground. The driver wasn't given any way to check that grounding and bonding were working. The employer's SWPs didn't favor or prohibit any of the top or bottom loading methods mentioned. The driver chose to top load. Although the use of personal protective equipment, or PPE, was mandatory, the driver wore casual clothing and running shoes to perform the transfer. The only pieces of PPE he wore were the gloves. The driver started the tanker truck and engaged the pumping system. He opened compartment 4, which held diesel, and compartment 3, which was empty. The driver likely displaced the remaining diesel in the dispensing hose into compartment 4 and then began to splash load gasoline into compartment 3. All 3 components needed to start a fire were present: fuel, oxygen, and heat. Gasoline was the fuel. Vapors from it mixed with oxygen from the air. For heat, a spark would be all that was needed to ignite the mixture. And it was identified that the 3 most likely sources of a spark were: 1. The turbulence of splash loading could have generated a charge difference between the nozzle and the tanker, leading to a spark. 2. The static charge created by the flow of gasoline transferred to the nozzle. The nozzle, because it was not bonded to the dispensing hose or the rest of the tanker, was an insulated conductor. This was very hazardous, because it could build up a charge and then discharge it to another part of the tanker, leading to a spark. 3. A charge from the driver and his synthetic clothing. There was no evidence that the driver was bonded to the tanker truck during the fuel transfer. Soon after splash loading began, there was an explosion. A fireball rose from the tanker truck. Flames from the ground reached the height of the tankers. There was no fire control system at the site. Workers from adjacent businesses called for emergency services and banded together to fight the fire and help the seriously injured driver. The driver repeatedly asked the workers to close the valves on the tankers. None of the workers knew how, but one shut down the truck's engine. Using handheld extinguishers, the workers put out the fire. Emergency services treated and then transported the driver to hospital. Sadly, he didn't survive. Multiple factors contributed to this incident. The employer, the fuel distribution firm, failed to ensure that the ignition hazard from static discharge was controlled. Specifically, they didn't ensure that systems for bonding and grounding were present, tested for effectiveness, maintained, and regularly inspected at their workplaces. The employer's health and safety program failed to detect and control the hazard. Responsibility for effective bonding and grounding at the work sites was left to the drivers, yet they weren't given a method or equipment to verify it. Unsafe practices that occurred included splash loading and failing to use the supplied PPE and to deploy guardrails. Supervision was inadequate. Observations or evaluations of the driver in the field weren't done for nearly a year before the incident. Safety inspections were not conducted at the site at the frequency specified in the safety program. Plus, the inspection process didn't check that effective bonding and grounding was in place. Senior management didn't detect and/or correct these oversights. More issues at this site included that the driver worked alone during the fuel transfer. There was no fire control system at the site. The employer hadn't ensured that assistance would be readily available during an emergency. They also failed to inform the local fire department that bulk fuels were being handled and stored for extended periods at the parking lot. The control of sparks during top loading depended on the consistent following of safe work procedures. When that didn't happen, an explosion and fire resulted. For such a serious hazard, relying only on procedures to protect workers isn't enough. A higher level of protection is necessary. Here, it meant engineering controls, as in effective bonding and grounding systems. Having those likely would have made all the difference.